Does that make sense? Do we remember doing that? Okay. So today we're going to be solving more proportions, okay, using unit rates, mental math, and cross products. Well, unit rates is something we had to know too. Who has the definition for unit rates? I know somebody did. I think I spoke to, was it you, Athena? Athena, where did you find that?
On page 232, and the definition is rate for 1 unit of given quantity is the addition of rate. Unit rate defines a rate, divide the first quantity by the second quantity for the rate of.
Okay, so first she said, I'm going to go back because it's hard to hear, Athena. The rate for 1 unit of a given quantity. Just 1. I don't want 25. I want the amount for 1. Okay? Then she said to find it, you would use division. How many people agree with that? How many people use division in their flashback? Okay, so we're definitely on the right track here. Good to know. Mental math, what's mental math? We already know that. We've been using it since, I don't know, 4th grade. What's mental math?
Solve a problem without writing.
You're doing the math where? In your head. Some of us, we're like that with mental math. Some of us, it takes a little longer. That's okay. Okay? We're going to be using it today. Do you think we're always going to be able to use mental math? When do you think we're not going to be able to use mental math? Natasha?
When we have like long problems.
What do you mean by long problems?
Like if we were to have like decimals or maybe like decimals like 4.1 something.
Well, I don't know what's decimal. Everybody gets the decimal, the poor decimal. The decimal we learned is really a fraction, right? But I agree with Natasha. It's not always easy to do mental math with decimals. Okay, that's true. What do you think, Renee?
I think that you're gonna have to use this year. Not gonna be able to use mental math when you have a problem that needs to be solved out completely.
Okay, like maybe a longer word problem? Is that what you're kind of hinting towards here? How many people agree with Renee? I probably wouldn't use a ton of mental math if it's going to be a longer word problem. Probably not. You might use parts, but it might not be enough. What do you think, Ephraim? A long algebraic equation or problem? I would agree, definitely. What do you think?
When you need to divide and they're not compatible numbers.
Oh, say that again.
When you need to divide and they're not compatible numbers.
Compatible numbers. When did we use compatible numbers? Well, we did use them last year, but we didn't call them that.
I think it was chapter 4.
Well, we used them in chapter 4, we used them in chapter 1, okay, when we used estimation. Do you guys remember we estimated? Always a good thing to know, okay? Cross products. Is that familiar?
Yeah.
Eliani, do you remember what the cross products are, that method we used? If you're not sure, you take a minute. Everyone take about 10 seconds to think, when did I hear cross products? When would I use it? The cross products method. Because it looks like some people remember. I've got some hands up over here. So I'll give everybody about 10 seconds. Formulate your answer. And you're going to tell somebody next to you what the cross products is. Go. And Eliani will be able to tell me. Athena's got it. Carmen, you got it? What page is that? Carmen, check out the Eliani, you ready? All right, Eliani, the cross products is what? What is it? She said the products found when you multiply the numerator and denominator of 2 ratios. Look what I got here, Eliani. I got 6 to 8 and 9 to 12, the same one I did here. I checked it using the cross products. I multiplied the denominator of this ratio to the numerator of this ratio. I multiplied this one to this one. Cross. Doesn't that make sense? It makes a what?
Cross.
Cross. It makes sense. 72 and 72. If it's the same number, do we have a proportion?
Yes.
Yes. How many people use this method typically to solve? I like that one. It's a quick one. When don't I like that method? I think I talked about this before. And when some of you said, too, you don't always use that method. Why?
When you have big numbers.
Yeah, I'm not going to sit there and, if I get like 276 and 34, I don't know if I want to use it. Maybe I can simplify, which was another method. Okay? You like the cross products, Renee? Is it just easier for you to multiply? Okay, and that's fine. It'll work. Let's go back and finish going over your flashback, and then we'll go to the preview question. Okay? Let's see if our math skills, because it sounds like you guys remember this information. The first question, when is a ratio a unit rate? Well, I think we talked about that in the beginning a little bit. When is a ratio a unit rate? So what do you guys think? So when would a ratio become a unit rate? That's kind of a tough thing to think about. Renee, what do you think? Okay, sometimes you will simplify it. I would agree with that.
I think it's like you're representing more than one thing, and I don't know. And then it's like then you gotta figure out how much is the cost for one.
Say it again.
When it's representing two things, and then you gotta find the cost for one thing.
Okay, so Ephraim said, I'm going to maybe rephrase it in different words, but same idea. He said when you're getting the cost of something, like let's say, there were 18 juice boxes in the container that you're at the supermarket and you're shopping with mom, and the total container costs $4.97. Could I figure out how much each juice box cost? What would I do then to do that? Divide. Do you see how that's now a unit rate? Okay, so when we look for how much does one cost, if we know how much one costs, could we figure out how much a million cost? Could we figure out how much 97 cost? So is the unit rate important to figure out, especially when you're shopping? Why would I make that connection? Why is it important to know the unit rate? What do you think, Jordan? And then we'll ask Natasha.
Say you buy a pack of soda.
Ooh, sorry.
You buy a 6-pack of soda.
Yep.
I'm trying to find how much for just one of them. You buy more than one.
Okay. So you're purchasing soda is his example. You want to find out how much the cost is one can of Coke. Well, let's say, Jordan, I'm buying Coca-Cola, like the flavor cola, and there's Pepsi and there's Coke. And there's two different prices for a 6-pack. If I find the unit rate, will I figure out which is the better buy?
Yeah.
You say, yeah. What do you guys think about that? You said, yeah, why?
When we did some problem, it was like a word problem in I think it was in our book, in our workbook.
Okay.
And they told you no, it was on the test. It said which one is better choice. And it said if you have 6 ounces, you get $2 for 6 ounces, $12 for 13 ounces like that. And they asked you which one were the better buy.
How many people remember a problem doing a problem like that, like Renee's explained? Does that seem familiar? Renee, that makes sense to me. Does that make sense to everybody else?
Yeah.
So if you are on a budget, do you think knowing the unit rate for things is important if you want to save money? Yeah. Okay. I want to give you an example of when we talked about, this came up, a ratio came up in my everyday world. I went to pick up my daughter at daycare, and her teacher, we're talking, and she says, on Monday, there's going to be 10 babies in here. I said, wow, and I don't know if you guys know daycare, but, having 10 babies in one classroom, that's a lot of babies, okay? And I said, wow. She goes, yeah, and the ratio to babies to teachers is 4 to 1. I said, oh my gosh, I'm teaching ratios to my 7th graders. This is a great example that I'm going to share with them. So, if the state allows 4 babies for every 1 teacher, that's the unit rate, isn't it? They can only allow for that one caretaker to take care of 4 babies at one time. That's the legal law, okay? But she said, there's going to be 10 in here on Monday, and I know Carly has 2 teachers in her classroom. So, legally, we have to have a 4 to 1 ratio for babies to adults. Okay? And right now, okay, we have 10 babies to 2 teachers. How can we figure out, are they in legal standing? Meaning, is this what's happening right now in her classroom? Is it legal? Athena, what do you think?
No, because there's 2 extra babies in this school.
How do you know there's 2 extra babies?
Because 10 divided by 2 is 5.
So what did she do right now? She simplified this. And what's the ratio right now with the babies? It's 5 to 1, but what does it need to be?
4 to 1.
Oh.
You need another teacher.
You need another teacher. So she then said, because you got me there, this is what I'm doing in my head. Athena's math is what I'm doing in my head when I'm in the class, when she's saying all this. And I'm thinking, oh, they're going to need another teacher. And she goes, yeah, so Miss Nora is going to come in on On Monday, she's going to be the third teacher in the classroom. Okay? So, then she posed this. I'm going to take this one step further. You ready? My daughter is moving out of that classroom. She's 10 students. There's 10 students, babies. She's moving out. So, now how many students will there be? 9. Right?
It's still one extra. 4
There's 4.
Now it's a what ratio?
9 to 3.
9 to 3. Let's simplify it just to get the unit rate. What did you divide by?
3.
You still need an extra teacher.
Now it's a 3 to 1 ratio. If they keep this third teacher in, correct?
Yeah.
Are they legally okay now?
Yes.
How do you know, Ashley? It's under the 4 to 1 ratio. So do you see how it's something that seems so simple? Like when I walked up to pick her up from school, all that math came into play. And it seems really like, whatever. It makes sense, though. We use it every day. And we talked about this when you go to high school, and we took a look at class sizes. You know, do you want to go to a high school where the ratio is 40 students to 1 teacher? Or do you want to go to one that's 20 to 1? Okay, so it's stuff that you have to think about. These are ratios, okay? Comparison of quantities. Yes?
Well, my cousin, it's a book, right? It's a high school book, and it shows you all kind of high schools and near her and around her.
Uh-huh.
And she was looking at it. It was a classroom, and they told you how many students were in that school, and then how many teachers there were.
Uh-huh.
And it was like 100 and something kids, and it was 20 something teachers. And then that's when she kept doing stuff where she kept writing stuff down on a piece of paper, like math and stuff. And I was wondering why she was doing that.
So what was she trying to figure out, Renee?
She was trying to figure out if she'd get the help that she needed.
Exactly. Because if I know that there are less students in a class with a teacher, most likely I want my kid to be in that classroom. Okay? Good. Those are great connections. Okay?